Welcome everybody. Let's talk a little bit about reparameterizing with respect to arc length. And for that we need to start with what our arc length function was. So we have s of t being the integral from a up to t of the square root of dx dt squared plus dy dt squared dt. And t was going to be a function, t was going to have values in between a and b. Now, since the integrand is positive, we know that this is going to be an increasing function of t as t goes between a and b. And so, in particular, what that means is that since we're increasing, that s has to be a one-to-one function. Now, because it is a one-to-one function, it means that our inverse exists, and that we can really rewrite our parameter t to be a function of the arc length s, so that we can actually have t as a function of s. Now, this new parameterization would look like gamma of t, instead of being x of t, y of t, of z of t, then becomes gamma of s being x of t sub t of s, y of t of s, and z of t of s. Now, one nice thing, this parameterization really has some nice properties to it, and kind of start looking at those properties. If we go back to our function and we talk about taking the derivative ds dt, then the fundamental theorem of calculus says that this is really just going to be the length of our tangent vector. Now, the chain rule, if we take the derivative of r with respect to t, then we have dr dt as being dt ds, and dr dt as being dr ds ds dt. Well, we just figured out what ds dt actually looks like. And for that, it's really nothing more than the norm of the derivative, so the norm of the tangent vector, so that dr ds looks like 1 over the norm of the tangent vector times the tangent vector itself. And so what that means is that the derivative with respect to the arc length is always going to be a unit vector. And since it's a unit vector, we actually call it the unit tangent vector. So the unit tangent vector being defined as the tangent vector divided by its norm, or we could take it as t of s being the derivative of r with respect to arc length. Now, because it is a tangent vector, we have that t dot t is going to be 1. And so if we take the derivative of both sides of that, and on the left-hand side, we've got the chain, or we've got the product rule. So the derivative of the first dotted with the second plus the first dotted with the derivative of the second. And the right-hand side was just a constant, so the derivative ends up becoming 0. Now, what that gives us is that the derivative of the tangent vector, the derivative of the unit tangent vector, dotted with itself is 0. And so kind of the super important idea that we'll take away with this is that the unit tangent vector is going to be orthogonal to the derivative of itself, to the derivative of the unit tangent vector. Okay. And where this is going to start coming into play a little bit later is when we've start talking about normal vectors and binormal vectors, and that is a video upcoming. So hope to see you guys for that one later.